Okay, so in this problem, we want to find the area inside one leaf of this rose. So first of all, let's understand why this is called a rose, what this looks like, so we can set up our integral. First, recall that the sine function looks like this. This first part here, the sine function is positive. It's above the axis. And when x goes from 0 to pi, the y goes from 0 up to 1 and then back down to 0. So again, it's above the x-axis. It's positive right there. When the inside of the sine function, when that x goes from 0 to pi. So when we look at our function of theta now, 10 sine of 8 theta, that will do kind of the same thing, except in polar coordinates it gets wrapped around a bit differently. But still, it will be positive. This radius will be positive when the inside of the sine, 8 theta, when the 8 theta goes between 0 and pi. Okay, so that radius, the distance from the origin, will be positive or non-negative when the inside, the 8 theta, goes between 0 and pi. So what would that mean for theta? Well, divide by 8. Theta would go from 0 to pi over 8. Okay, so how this would look. When theta goes from 0 to pi over 8, the radius starts at 0, right here, increases until we get to 1, or in this case 10, because we're multiplying by 10, right? 10 times sine 8 theta, until we get to 10, and then it goes back down to 0 by the time we get to pi over 8. And then as we go from pi over 8 to pi over 4, well, that's going to be the negative part. So we're going to be inside this region here, inside this region, but it's negative. So it's going to be on this side. So it's going to continue on, look something like this. And then we will be positive again. And you see we start to get this pattern. And we don't need all of this for the problem, but this is what the thing looks like. And in fact, at this point, no, never mind. So so you keep getting more and more pieces, and so on. Okay, so it completely fills out this thing. But anyway, what we want to know is what is the area of just one leaf? We call this a leaf right here. So we don't need to know the whole graph. We just need to know what does one leaf look like, and how do we find the area of it? So we know for that leaf, theta goes from 0 to pi over 8. So we didn't have to draw any of that, really. All we had to make use of was this fact right here. So we get one positive portion, one leaf, when the inside, the 8 theta, is between 0 and pi. And then solve for the theta. So that theta will be from 0 to pi over 8. Okay, so that means for our area, this was our formula, goes from a to b, 1/2 r squared d theta. So in this case, we're going to be integrating from 0 to pi over 8. 0 to pi over 8. 1/2 r, now r is 10 sine 8 theta, squared d theta. So let's multiply this out. Square the 10 and square the sine. Get the integral from 0 to pi over 8. 1/2 times 10 squared, well, that's 50. And then sine squared of 8 theta, rather. 8 theta. And then we make use of this identity. Sine squared of x is 1/2 times 1 minus cosine of twice the angle. That's the double angle formula for cosine, rewritten in terms of sine squared. So in this case, the sine squared 8 theta would be 1/2 1 minus cosine of twice the angle, twice the 8 theta, it's 16 theta. And then we can work this out. Now 50 over 2 is 25, and I can bring that out. 1 minus cosine 16 theta. And then we need to find an antiderivative. So the antiderivative of 1, normally we think it's x, but it's theta in this case. The variable's theta. Minus cosine, well, what's the antiderivative of cosine? Sine of 16 theta, and divided by a 16, because we have the 16 times theta inside. So that's how you do a substitution. If you let u be the 16 theta, you see we end up dividing by a 16. And then we evaluate this from 0 to pi over 8. So let's plug these numbers in. Plugging in pi over 8, we get pi over 8 minus 1/16 sine of 16 times pi over 8. Okay, and then minus, when I plug in 0, of course I get 0 here. And then sine of 0 is also 0. So I get 0 for both of those. Now let's see here, 16 pi over 8. That's 2 pi, right? So in fact, sine of 2 pi is also 0. That is 0. So I'm left with 25 pi over 8. So that would be the area of one leaf of the rose.